Hey team, welcome to my channel. Today we're going to talk about Azure functions and we're going to discuss a few interest topics that in my opinion you can easily find them on internet. And the reason I want to highlight these specific topics is because well, first, you will not find them easily. Second, most developers don't acknowledge the problems when they configure the Azure functions, the host, the cost, the host solution, the plan that they are going to use. So there is a lot of trade-off that you need to be aware of. And my intent here is to give you some clues using one of the most important videos that I saw discussing the topic I just mentioned about. But first, if you don't know Azure Function, just give you a quick overview. Azure Function is a serverless solution that allows you to write less code, maintain less infrastructure, and save on cost. Instead of worrying about deploying and maintaining a server, the cloud infrastructure provides all the up-to-date resources needed to keep your application running, which is true. You focus on the code that matters most to you in the most productive language for you, and Azure Functions handle the rest. So the whole idea with Azure Functions is that you choose your preferred development language, okay, from the list that is supported currently. You choose a specific models, a specific plan for running, and provide some specific CPU and in general resources, CPU or storage to run your process, and you basically connect or this specific function with different workloads or with different other services. Okay, the whole idea is that they abstract all the infrastructure configuration that you might do manually or automatically if you are running Docker, if you're just creating a web job or specific or another specific services, right? So the important thing here is that there are many important arguments and triggers and bindings. I want to talk about really quick about triggers and bindings. And I think this is one of the best advantages of using Azure Functions. You can implement your own code. You can, for example, do all your own transformations on the data or any request API or any data that you are reading, or you can implement a trigger-based solution really quick, depending of inputs and output, and these input and output services can vary in many ways. Okay, they have right now a lot of support bindings. Okay, they have blob storage, Cosmos DB, Data Explorer, SQL, Event Grid, Event Hub, HTTP webhook. They support webhooks. You basically can, for example, attach API management, which is API gateway in Azure with this specific function, and you can basically have an API with these two services. You can do a lot of things with Azure Functions, and I believe they are really good. But what we're going to discuss today is about cost model. We're going to discuss about pricing plans, the nature and the importance of selecting the right the pricing plan so you can scale in or out depending on some specific configurations. And we're going to also try to understand the impact of the dependencies that you're going to use in your code. Okay, and for that I'm going to use this video. This video is really good. So I'm going to skip a little bit. I'm not going to read it all because it's around 1 hour video, but I think it's very good to understand what Ian Griffin is talking here. Ian is a Microsoft MVP, and he seems to have a lot of knowledge on Azure Functions. And I think this is one of the best video explaining things that no other practical videos explain about Azure Functions, which I believe is very important. That's what I have here on my notes, and I want to talk about today here. But let's start listening here.
And move over to a cloud-oriented approach for processing that with a kind of balance between frequency of processing and efficiency of usage. And we used Azure Functions as part of this. So there was essentially a recurring job that ran and did batch processing to ingest and process data for them. To ensure.
So it's important that you can understand that Azure Functions can be used in many ways. Okay, but they started the framework with web jobs, so they can similar starting using Azure Function as web services or recurrent web services. But you can do a lot of things right now. Depending, as I mentioned before, you have a lot of bindings. You can develop API, ETLs, data pipelines. You can do background processing. You guys have timers. You can respond and do reactiveness. applications using Azure Function. The whole SDK it just got bigger and better. So yeah, it's valid to mention that one.
Sure that they were able to do the analytics they wanted in a timely way, but in a way that wasn't, hugely expensive to run. So it's not anything different from what you might do with AWS Lambda. The basic idea is that you need to run jobs from time to time, which are typically triggered by internal requirements. So it might be timer-driven things, it might be messages arriving on a queue, it might be conditions being met somehow that trigger things to happen, it might be just communication within services that are not publicly exposed to the outside world, but where you just need a compute node to run some code on to get some work done, usually for a fairly short amount of time. It might be a few seconds, it might be a few minutes, it might be a few milliseconds, but it's probably not going to be hours or days in all likelihood. So it's those sorts of jobs. So yes, processing that kind of data. We've also, actually an earlier thing I worked on, which actually ran on the predecessor of Azure Functions, which might be a useful thing to get into just to understand what Azure Functions really is and where it came from, was a system for spinning up virtual classrooms. So we worked on a project where people could essentially run labs where people needed access to machines configured in a certain way, so they could do hands-on labs as part of a training experience. And we automated the provisioning and scaling up of large numbers of virtual machines, so students actually had machines they could go and do the labs on without having to, pre-install a whole load of stuff on their own laptops. And I used to do loads of training back in the day. And the way we used to do it was someone would turn up at the weekend and install software in a room full of PCs ready for the Monday morning training to start. So this was automating that kind of work. And again, you need something that can sit and orchestrate a long-running process and that can recover from failures and just push through and make sure everything happens. And we were building that actually on the predecessor to Azure Functions, but it basically that developed into what became Azure Functions today. So yeah, orchestrations and recurring work and sort of internal processes, it's all those sorts of things.
Yeah, he just basically explained here the main requirements where you will use Azure Functions services.
I do remember reading about something similar to on AWS side. You have AWS Step Functions, which is kind of the service that lets you kind of build and model your business workflows as a state machine. On the Azure side, I do remember there was something like was it Logic Apps?
Logic Apps.
Okay, Logic Apps. You have in AWS you have Step Functions, and in Azure you have Logic Apps. It's basically a no-load code tool which you can configure your workflows, your triggers in the same way. So you have, it's an EPAS services also, Azure Logic Apps. I use Logic Apps a lot. And I think the best advantages between Azure Functions is that you have a lot of connectors that are easy to program or to configure using just the portal, the Azure portal. Let me show you here. And the other advantage that I see between these two is that let me see if I can find you some of the okay, I want to find all the bindings on the Azure Logic Apps, all the binding that you have. You can basically you have a low code, no code tool where you can configure the all your workflow orchestration workflows without adding any new code. In general, you are not adding code, but at the end you are just using JSONs to create a template on the code side, which is analyzed by by Microsoft then, and they understand how to process this information and create a workflow for you. But I believe this is a valuable tool. So you have these two, in general, you have these two tools, Azure Functions and Logic Apps, to create workflows, ETLs, serverless services in solutions in Azure.
Yeah, that's it.
Yeah, so I would say they are a slightly different part of the Microsoft house. So Microsoft has always had what we sometimes refer to as clicky, draggy, droppy type experiences, because a large part of Microsoft's history is really empowering people to use computing in a way that used to require an IT department, right? Yeah, it's like a lot of the things Microsoft done were trying to put power in the hands of individuals, and they didn't necessarily invent the things that they did. Obviously, spreadsheets were already around before Microsoft brought them in, but Excel now is kind of, it powers half of the financial world. And I think they're trying to do the same thing with Microsoft Fabric as well. And I think that for me, the logic apps fit into that low-code, no-code type approach, where you're trying to enable someone who knows what they want to do and can describe the process to be able to get that set up and put in place without necessarily having to be able to drive a compiler.
Which I believe this is the idea that Microsoft has, to give someone that doesn't have the code expertise and create this type of workflows. But from my experience, sometimes you need sometimes you need a lot of time to understand the connectors, the binding, or how to configure them. So I believe that the easiest workflows that you can build, maybe not technical person can use them or can learn to configure them easily, but it's more than that, guys. I believe that you need a fairly programming understanding on how to create or code, or at least procedural coding, so you can create this type of workflows, including no-code, low-code tools.
And I think these days probably Microsoft would drive people more in the direction of Power Apps and that kind of world rather than Logic Apps. I see Logic Apps as being the kind of logical predecessor to that, but they were kind of connected to apps, to the Azure Functions world. So you're right, there's a connection there, but I see that as sort of, it's more morphed off into a separate thing from the app service world that it began in.
Right, gotcha. So I guess in this case, I've not played around with Logic Apps in the past. I did try out Azure Functions briefly, and I know a few friends who's done some projects using Azure Functions. And one of the things that kind of really stood out for me compared to AWS Lambda is the fact that it's actually using Docker under the hood, and I think it even exposes the underlying container instance so that you can potentially connect to it yourself directly. Is there, I guess maybe, can you talk us through how does Azure Functions work, and maybe how does it differ from Lambda?
Okay, this is a very good question. How Azure Functions differ from AWS Lambdas? Let's listen to this.
One important thing to know is there's actually two different ways of using it. So yes, you can use it in an explicitly containerized mode. But that's actually, as far as I know, that's only available on Linux. So if you build Linux containers, you can host them inside the world of an Azure function. But that's actually, most of what we've done has not been that way. We actually tend to, for historical reasons, have mostly built them on the Windows.
Well, basically, you don't want to go to that route. If you have to do some infrastructure configuration, I bet that you may go with other flexible framework, or maybe approach is the better word to use. You can create a worker service, and you create a Docker, and you can deploy whatever you want. You can create a Docker container, you can containerize your application, you can deploy whatever you want. So if, on my opinion, if you are in a specific case that you have to do some infrastructure configuration, I think you are missing, or you are just you're missing the big part of Azure Functions. On my opinion, I know that you can host your Azure Functions in a specific app service include also in a specific container with Linux. I'm not sure if they already configure, if they put available Windows as a host there. But in my opinion, if you start configuring infrastructure, there may be 8 cases that I don't know that you might need to use them. But every time that I had to configure some infrastructure host provider, I will go to a worker service in a container app.
Platform. So there's a Windows version and there's a Docker and a Linux version. They are the same API because you're writing .NET code in both cases, and it's all .NET Core. It's just, are you compiling for Windows or Linux? Same source code could in principle run in either if you're avoiding any particular system calls. In the Windows one, it is containerized, but you don't get to see that you're using the kind of internal containerization system that Azure itself is built on top of, and they do not surface that to you in the Windows world, and they've actually changed what they do under the covers a few times. None of the details of that are public, but the specifics of the containerization system that it's built on have not been the same throughout the entire history of Azure Functions. Whereas if you do use the Linux containerized version, then obviously it's a bit more stable because that is officially part of the public API, and yes, you can talk to it. So with the Windows version, you can also kind of connect to it. You can get a command prompt into it. You can even attach a debugger to it and debug stuff up in Azure if you want to through Microsoft's development tools. That all works, but that's all basically done over sockets, so you don't really know quite what you're talking to. And if you poke around on the machine from inside of a process running in an Azure function, it's sort of clear it's not quite a normal machine. It's some very specialized environments. Actually, let me give you an example of this. One of the examples I give in my cold start talk is another thing Engine did with our with functions was badge rendering. So you know those little badges you get saying when things were last built or when they were published to this package repository. You see them at the top of READMEs in a lot of GitHub repos that will say, this is the latest version. It will have a link to UGet or to PyPy or whatever package repository you're using, and people tend to use. There are public sites like Shields.io that will render these things for you. But we needed some of our own. We were doing some badges that actually represented IP maturity. So we're measuring things like how recently has there been a code review? Does this conform to certain coding standards that are set up by the company?
They're going to skip this part.
Will be somewhere.
Let's go to talk about.
You can now say actually your usage model.
Probably for cold start.
This is important. This is an important question. It's related with cold start, the issues on Azure Functions, how fast they start, and the issues between. And I think this is very important to understand, guys. Okay.
App and it's talking to an API. Customers as it is for Lambda. With Lambda, there's a lot of people building, user-facing APIs with, various different API gateway or some different options. But ultimately, when you got a user that's hitting your app and is talking to an API, cold start, even for just more than a second, is potentially a problem, especially when you've got API talking to API and all Lambda function behind the scenes. So the cold start starts to stack up. Is that something that you see people doing in terms of building entire applications out of Azure Functions and having the problem with the cold starts?
It's a thing you might need to work at. It really depends though on your usage model, because there are different pricing plans with Azure, and the performance you get depends on how much you're prepared to pay. So
okay, this is a pretty important fact. So the pricing plans. Let's review the pricing plans. I think it's not this. The pricing plans vary on the hosting option that you have. Okay, and basically the main difference is the scaling and the services provisioning that they give to you. Okay, let me see if I can find more information here. So there is this web page is talking specifically about, I'm not going to read it to you, but it's talking specifically about best practice and pattern for building scalable apps with Azure Functions. But it's also talking about the difference between consumption premium plans and flex plan, which is the newest consumption plan they added just recently. I need to read a little bit about the flex consumption to see the difference. Yeah.
if your usage model means that you're going to be more or less permanently busy, then it makes sense to pay for one of the plans where you've essentially prepaid for a certain amount of compute that's always going to be available. And in those cases, generally speaking, even a cold start will be, I forget the exact numbers, but it tends to be in the sort of low milliseconds numbers, because they pre-warm instances up for you, so that the amount of time it takes between a request coming in and your code running, they work hard to minimize it, because they can dedicate some compute capacity for that, because you're paying for it, right? So whereas there is also a consumption-based pricing model available, where if you don't use the thing for 3 days, you pay absolutely nothing. But obviously, in that case, they're not going to keep computers sitting waiting for a request to come in on your behalf. And so in that world, there is a significantly higher delay.
Okay.
Now, you can still usually get it down to maybe a couple hundred milliseconds, which is not too bad for a thing that you've not paid for weeks. But
that's true.
If you don't design for that,
that's true. If you're not paying for something in cloud services and you get milliseconds request response model, that's a very good idea.
As you're developing, it's actually very easy to get yourself into a situation where it's much worse than that. And so, the example I gave of our little badge rendering thing, we did something that we didn't realize was going to have horrible performance and gave us like 20-second start times, which is obviously just completely unusable at that point. But that's not normal. That was an unusual case. So in practice, there are a few things that you need to do if you want to get the best out of the cold start performance. And it's not that different from AWS Lambda, to be honest. So one of the changes that Lambda made in their .NET SDK was they took advantage of the ahead-of-time compilation features that got added to .NET a couple of years ago, where rather than doing all of the JIT compilation, all of the translation from IL into machine language at runtime, which has been the default in .NET forever, you can now say, actually, I'm going to emit pre-compiled machine language for the architecture I know I'm going to be running on in addition to the IL, and so the JIT compiler doesn't have to do anything at startup. The thing can just run immediately. And that often makes, sort of 100 millisecond type difference to startup times, possibly more depending on what you're doing. So, for example, if you do dependency injection, it's very easy to write code that touches every single component in your system a teeny bit on startup as part of its initialization code, whether it needs it or not. And that can actually, if you've got sort of 40 dependencies, you can suddenly be looking at start times of over a second very easily, whereas the pre-compilation technologies actually do a very good job of flattening that back out.
I don't want to interrupt this part, so that's why I'm so quiet, because this is the very important part. It's just talking about the difference between hot and cold starts, and this information you don't find it anywhere, guys. And this is from top real product experience. So let's listen carefully.
Acceptably fast, even for a full cold start. But like I said, that tends to be the biggest issue with the cheapest plans, the ones where you pay nothing if you're not using it, because you really do have to start totally from scratch with those.
But guys, if you're learning to use Azure Function, you're not paying for anything, you can get very decent latencies numbers with consumption plan, which is basically the first tier plan that they have, and you basically pay almost nothing, okay? Which I believe this is very good. Now, when you go to a premium model or flex model, now you have all the challenges depending on the scaling, because the hard thing here, on my opinion, is to understand the scaling necessities of your systems, okay? So you can really configure this to be cost effective, because maybe you are just adding more resources than the one you need. And not all cases you have all the data, as I say in the beginning, not in all cases you have all the data to understand the processing throughput or the data throughput or the availability metrics that you need to provision to the specific vendor, or there are a million reasons why you don't have all the data to make these decisions along the way. So sometimes you have to make them after you see your process and you start improving and iterating upon it.
Microsoft has done a lot of work on the higher price points over the last few years to significantly improve the cold start in the case where you're prepared to pay a recurring fee every day to keep the lights on. So in those situations, they do actually pre-warn things. They load your code ahead of it being needed on new nodes. They don't bring those into service until it's ready. Because one of the features, for better or worse, of Azure Functions is that they assume you're okay with your code running for a long time. The basic assumption is you're probably going to start a process, leave it running maybe for hours, possibly days between reboots. And so you're going to amortize most of those startup costs. You're going to average them out to be very, very low, because the overwhelming majority of your requests are not going to be cold starts, but the consumption-based pricing plans often change that. They often mean, well, actually, most of your requests may well be cold starts, because presumably the whole reason you went for that model is that you expect to spend large amounts of time idle enough that everything spins right down again. So it does depend on the usage model.
So that's interesting because Lambda has also done very similar things to what you described in terms of having this to-do pricing structure. On the Lambda side, they call it the provision concurrency. So essentially, you pay for.
Yeah, I believe they are getting, so the people that are implementing these services in AWS and Azure, they are competing against with. And I believe one of the things that they understand they have to get right is the cost pricing model, depending of the provisioning of the resources they give for a specific hosting plan. And I believe they started, I think they have improved a lot since I started using Azure Functions. So I have a friend that told me, hey, I don't use Azure Functions because when I started using, I just used, there was like 3-5 years back. It cost me like a couple of bucks to do some testing. Imagine if I was going to learn, it cost me, learn Azure Function, it cost me $100, for example. I say, well, right now you can learn it and basically for free. So because the hosting pricing models are just changing and they're improving because they're doing a lot of tactics like Ian just mentioned, changing the compiling dependencies, order, depending on the host provisioning resources that you use. So there is a lot of tactics they add here, so you can get better price model.
Function, to be,
of course, Azure is also scaling, and AWS is also scaling, and they're getting bigger. So that now they can afford better prices to the clients. That's also true.
Warm all the time so that you don't have to think about the cold starts. But I think on Azure side, looking at the pricing page, they're not charging you based on a number of instances, but rather based on virtual CPU hours and also by memory as well. So I guess how does that translate to number of actual instances? I guess stock instances of your function. Say, if you're paying for certain amount of vCPU, is that if it's not like a whole unit, like one virtual CPU, do we just get like a fraction of the time on that instance?
It's not that clearly defined. They've deliberately left it a little bit on the fuzz.
And here we go. This is one of the most important part on the cost pricing, hiding things that I was just mentioning to you about. Let's listen, Ian.
The side.
Let's go back to the question.
Charging you based on a number of instances, but rather based on virtual CPU hours and also by memory as well. So I guess how does that translate to number of actual instances? I guess stock instances of your function. Say, if you're paying for certain amount of vCPU, is that if it's not like a whole unit, like one virtual CPU, do we just get like a fraction of the time on that instance?
It's not that clearly defined. They've deliberately left it a little bit on the fuzzy side. And really, I could be wrong, but I have the impression that it's set up in such a way that if you're using it enough, that the charges are high enough that you need to know the details, that you're probably better off going on to one of the higher price points anyway. Because once you move on to the premium pricing plans, where there's always at least one instance switched on, it's a little bit easier to work out. It does actually then translate more directly into you have this many CPUs there. But it is a thing that we found difficult over the years, is getting an accurate, getting a complete pricing model for customers. I don't think we've ever had it be wildly wrong, but it's often taken quite a lot of work to understand the workload the customer's going to present in order to build the right pricing model in advance, because it's not always that.
And that's what I always mention in one of my videos. Most clients, they're spending a lot of money because it's very hard, even for these high technical people, it's very hard to get a right pricing model for the requirements that any vendor or each vendor can provision. So you need a deep understanding of how these services work, which most developers doesn't have. Okay, so you understand the fact that you can deploy a natural function, put it there, receive some HTTP requests, build some trigger-based solutions. It doesn't mean that you really understand how to configure these services and the trade-off you have to make on your entire solutions to make it effective for a specific vendor.
but obvious what it is going to do. So, for example, we were surprised by the extent to which Azure Functions is happy to scale out quite early on. So if you give it a sudden large quantity of work, we were sort of expecting it to dump it all on one node to begin with and then gradually spread out. But it actually seems to go into quite an aggressive mode of going, oh, you're busy, right? I'm going to spread you across loads and loads of nodes. But because you're not paying for the actual nodes themselves, you're really paying for how long your code is running for any particular request. It doesn't actually make any difference to what you are charged. But you need to know that that's happening in order to work out how to optimize the code, because again, startup costs start to become significant there, because if you're running once on 1,000 nodes, that looks very different to running 100 times on 10 nodes, right? So you need to prototype and measure, we have found, to make sure that the characteristics you're seeing are the ones you expect. So we spend a lot of time building sort of fake models of the real system and just timing them and measuring them and seeing what the builds actually look like when they come in compared to what we thought they were going to make sure that we've properly understood how things are going to work.
Okay, so in that case, am I right in thinking that it's the same as Lambda in that one instance of your function, once it's been provisioned and initialized, it handles one request at a time, so there's no concurrency inside your function instance?
No, you will get concurrency inside a function instance.
Okay.
And again, once again, it depends on which pricing model you've gone for. One of the pricing models is actually to do with where Azure came from. So, where Azure Functions came from. So Azure Functions is a part of App Service, which is a set of technologies that Logic Apps was part of that. They also had a thing called mobile services, which might still exist, but I don't ever hear of people use.
So let's review something, the answer to this question, which I think I have it here for one of the consumption plans. Because concurrency is very important for this specific Azure functions, because you can deal with concurrency. Well, when you have when you write your .NET code, you can deal with concurrency in many ways. But in this case, you deal with the concurrency level that you need on the infrastructure side, which you can configure different instances, okay? And how you can do that? So basically, depending on your hosting models. So for example, the flex consumption, which is, I believe the flex consumption is a mix between the normal plan, which is subscription based, the normal hosting plan, which is the premium, and the consumption one, which is the basic one. I just call it the basic one. Okay. So as you can see, flex consumption. As you can see, they have the flex consumption, which is a mix between these two, and these are some characteristics that varies on this specific hosting model. But I just want to mention the characteristics, because you see the difference on the specific workloads they provide to you depending on the hosting model and instance sizes. So for example, flex consumption, I don't share a plan. You choose the memory or the instance needed on your workload. More memory can, oh wait, I have to share this in order so you can see it. Okay, now, so hosting models and instance sizes. Flex consumption apps don't share a plan. Choose the memory of the instance needed for your workload. More memory can handle heavy execution or have more concurrency dependencies on your workload. CPU and bandwidth increase accordingly. So you're basically allocating more resources depending on what you need. But there is important topic that I want to highlight here on the concurrency control model they have. So for example, you can have per instance concurrency in the number of parallel requests handled by each instance. You control the concurrency, but we all provide the file that works for most cases. Scaling is driven by concurrency and event source length. So you have, for example, 10 HTTP requests with a concurrency set to 1, and you can see how you get 10 instances, okay? But you can also get the same amount of requests, in this case 10, and you have concurrency set to 2, and you have only 5 instances. And this is impacting cost too. And there is an important, let me see if I can just put this, because I want to put this a little bit bigger. because I think this is a very important uh, data that I want to give you on the concurrency impact. And this is also for the flex consumption, but you can find it for the other ones too. But just want you to understand the difference between requests per second, the cost in USD, and the giga per second cost per a million of requests. And this is one of the greatest. This is the latest hosting plan that they added. Okay, so I'm assuming this is a little bit higher than the other ones. So concurrency impact example, comparing load test runs of the same application with instance memory size of almost 2048 megabytes with different concurrency values, 16, 8, and 4. Basically, they compare different concurrency configurations, and they check the response per second and the pricing model. Of course, the less concurrency, so let's continue reading this. Concurrency of 400 higher throughput for this particular workload, and it's scaled further. Concurrency of 4 also has higher cost compared to the other concurrency tested. So it depends on what you want to optimize for. The fact that you have the possibility to optimize for this is amazing, and I think you cannot do this with the premium consumption plan, and I think that's why they create this flex consumption hosting model. So basically, you have the 16 concurrency configuration by default, and you can have up to around 3 million of requests count, up to 30 gigabytes of data, and they cost just 50 cents, which is amazing. Okay, so in general, you will be paying for each million of requests 15 cents. Okay, let's go back to the video though.
Using it anymore, but there's also web apps a part of that. So if you deploy a web app, that's essentially the same infrastructure as an Azure function, and this comes from the roots of Azure functions. Is that the previous way to do the sorts of things you do in Azure functions was to create what's called a web job. So you would provision a web app which you would allocate a certain number of compute nodes to, and you could also say, oh, by the way, I'd like to use those same compute nodes to run periodical jobs or to run things when things come in off queues. So you essentially piggybacked it onto an existing web app, and for a while it was called a web app even if you were just using it for pure compute. And then over time they separated that out into this distinct Azure Functions offering, but you can still use it in that old mode. You can provision what they call an app service, or either an app service environment, or you can have an app service plan, which essentially is where you're paying for some number of VMs at some capacity, and then you can have several different web apps and several different functions all assigned to those compute nodes. And in that case,
I think he's being iterative here. So we already discussed about the hosting plan, the differences, concurrency configuration, cost configurations, and also the differences between the allocation of resources on this different hosting plan, and also the difference between cold start and hot start depending on the plan you choose. So I'm gonna try finalize this video talking about another important topic which is related with the dependency. Okay, so let's go.
In your experience, what has been the biggest challenges with using Azure Functions?
The biggest challenge, I would say, with using Azure Functions has been the fact that it's a black box. You don't know how great chunks of it work. And actually, lots of it has changed over time. So, and again, going back to these talks I've been doing about how to improve cold start, one of the interesting features of that is that I rerun all the tests each time I deliver the talk, and often things have changed. Even though I'm deploying literally the same compiled output that I was deploying 3 years ago. It's the same.
Yeah, he's mentioned about one important thing, black boxes. But the most challenging thing here is that the services that you start using today maybe is not the same as the service you end using in the next year. Okay, because they are pushing so much feature and so much changes into these specific services that if you, for example, and this happened to me, I used Azure for 3 years consecutively. I stopped using it for 1 year, and after that, when I tried to pick up the work that I left, there was so many differences on configurations, on triggers. Okay, the fundamentals remain the same, but to get it right, you need to constantly reading, and rereading and watching videos. And I think for the developer side, that gives you a bit of headache because you don't have the time to sometimes to get all the knowledge you need, because you don't have the time to put that specific skill set when you are delivering a process maybe in a short period of time.
Pushed up there, and the behavior is just different because they've changed something, usually with a view to improving something. So a lot of the changes in recent years have been specifically geared towards better cold start, in fact. So things just got better all by themselves without me changing anything. But the downside of that is that when things go wrong, it can be very, very hard to know where to look, because it's by design, it's platform as a service. You know, you're not given a VM, so you can't do all the things you might normally do to diagnose problems, because you just can't run arbitrary commands on the thing. You can't just install whatever on there and take a look at it. You don't have access to significant parts of the system. So, for example, one system we built was using the security features built into Azure Functions. So there are means of doing service-to-service authentication. So you can basically have Azure itself impose a requirement that only certain identities can call into certain functions. And that's quite convenient, but it's also completely unclear how it works. And we eventually discovered that the scalability of that feature was less than the overall scalability of Azure Functions as a whole. So you could create situations where authentication was your bottleneck. And it wasn't at all obvious that that was the root cause. It was only of a series of kind of A/B changes that we revealed, oh, okay, if we just disable authentication, this whole problem goes away completely. Obviously, you can't do that, but that was the thing. And it was weird. What we were seeing was just inter-service requests were gradually taking longer and longer and longer. And we worked out that we were sitting in some sort of queue inside of some component of Azure Functions that we had no control over, that was basically saying, oh, you need to be authenticated, right? I'll get to you in a minute, because there's a huge, long, big list of other ones I've got to work on as well. And the amount of compute that they had provisioned for things like just signature validation, you could overload it if you were doing requests too quickly. And it took us way longer to work that out than it should have done, because you just couldn't actually see any of the moving parts. It's like you're doing X-ray crystallography. You know, you're sort of throwing things into a black box and trying to see what pattern emerges from the other side. It's hard.
So yeah, with this line, we're going to end this video. So I hope you get a further understanding of these specific topics: calls, hop provider differences, call, how to start, dependency issues, the hard and the wrong side of having or using these platform as a services services on any cloud provider, and the benefit of using them. I hope you see you in the next video, and I hope you like this one. Let your comments down here, and see you in the next one. Bye guys.